I think we can start now. Good morning, all of you.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning, sir.
Morning, sir.
Morning, sir.
Morning, sir.
Uh,
Good morning, sir.
Morning. So I think all of you are present in the last class also, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
So
Yes, sir.
if you are not present, I think I have already shared the video with you in your WhatsApp group. You can look into that video and see every day. If you are just absent for today, just look into the recorded video so that you can understand and you can also interact with me wherever platform, whatever platform you want, and we can discuss about that. So is my voice audible or is there any disturbance with my fan something?
It's
No,
clear,
sir.
sir.
Sir, it's clear.
No, sir.
Audible.
No, sir.
So today we will discuss about some hardware. Say we were like slightly instructed to go a little bit slow, and so I am trying to use this time for explaining you whatever that is related to computer, because many people have to join and only few people have joined now. I think we have been filled with 60 something, but the thing is that maybe some people are waiting and all. So we are going slow. That's why I'm immediately not starting scratch programming. So our plan is like this week we are discussing about this hardware and any other related things. If possible, I can also start scratch this week because we have a lot of classes on Friday and also on Thursday. And in the next week, we will for a deep scratch programming, and then we will go for computational thinking and problem solving using Raptor. So before that, I have good scenarios for you which we can interact with and find out the computational intelligence, because it is purely related to data science also. So you need to decide what data, and it's really fun because of visual programming type of thing. And then we will go for algorithms and flowcharts. Then we start Python. So why this is suggestible? Because most of the courses that have been offered by Harvard or IITs or something, they start with a visual programming to gain students' attention towards programming, and they go with flowcharts and algorithms, so that it's a way of programming. So it's a way of starting from this programming perspective. The principles of programming always leads to, you need to first put out your idea on paper like flowcharts and all. Then you need to put out your idea as algorithm. So first of all, you need to write it like an algorithm. Every logic, for example, if I said find out the addition of two numbers, you will simply write a small algorithm, how you do it step by step. Step by step instruction in a most high level language using English, not even a programming language. And then we convert it into a diagrammatic format. Using these diagrams and the algorithms, you generally convert them into programming. So this is what really happens in software industry. Why people demand design is like your flow chart. The reason is, I will tell one example. One day a guy was suddenly dismissed from Infosys. This is the real-time example actually. This person was angered with the company, and what he does is, before going out of the company, he has deleted all the code that he has done, which is very important for them. Due to his misbehavior, they have removed him, and he again showed his attitude. So he removed all the programs from that company's server, whatever he has done, whatever he has access before he goes out of the Infosys company. And he has also teared all the papers that are related to that program, whatever that is taken as printout. He has put it in the dustbin with in companies there are dustbins, like you can tear the paper by sending them into the machine into pieces. He has done everything whatever he wants, and they have to deliver this particular product, which he is also part of the team, by another 1 week. They have no time, and all the program has been completely eliminated by this fellow. And they approached the design team because design team is separate in software companies. They generally draw diagrams. They generally draw flowchart type of things. In object-oriented programming, we call it as UML, Unified Modeling Language. So what this does is they will take the concept and put it on paper as diagrams. Using these diagrams, which are sent to the developers, to the coders, using these diagrams, they start to code. It's like, civil engineering. First of all, have you observed that while we are buying an apartment, we generally see the plan first. So designers will design the plan, and the real civil engineer who comes, they design it with CAD, CAM, something. I think you might be having engineering graphics also this time. So
Yes, sir.
it's a part of design of civil engineering and mechanical engineering. If you want to design a machine, if you want to design a particular building, you generally draw it in engineering drawing with all the length, width, everything. And this will be taken as printout and shown to you as a customer, okay, by the builders. But the real implementation comes only after this design has been seen, like how much uh, 10 by 10 bedroom or 12 by 10 feet, like that they divide, right, square feet something. So based on the design, the real product comes out. So in software industry also, the design is very important. So these people have took the designs from the design team, and they started to give it to the new developing team who are replaced with that fellow who has gone earlier, and they started to code immediately. That's the best process. And another example I had, like, I think it's our childhood favorite. First game that I have played in 1993, I think. Initially, I played in 89 or 90, and then I was given a gift like a TV video game. And the first game I have played is Mario. It's my favorite game. Have you heard about Mario game? It's the
Yes, sir.
most.
Super
Yes,
Mario.
Super
sir.
Mario.
If
Yes,
you
sir.
Yes, sir.
Sir.
Yes, I also played that. It's a very good game. Initially in 1990s, we kids are very favorite of this Mario game and Contra. These two games are very. And there is a small thing like Mario has a story. It was being developed by a Japanese scientist, maybe in America or something, maybe in Japan, I think. The next day, the vendors are coming and buying Mario. The thing that happened in the night is, by mistake, the entire code was deleted from his computer, and the next day he has to show to the people. So he was entirely confused and he was completely afraid of that. This was not mentioned in Wikipedia, but this was a story I heard from a lot of people, and also from some books I have read, which are inspiring. So what happened is, this guy, he sat all night, all night. We did not sleep, and he took all the designs that he has already made for the Mario, and he started to code again. The Mario which we played is actually designed in one night. Actually, what he has designed for 1 week, or 1 month or 2 months or 1 year, I don't know how much time he took for the original one, completed, because he has got some idea on okay, because this has got some idea on how to code, and he has also had designs in his papers. He took each paper and started to code again, and in a single night for 6 hours he sat continuously, and he has done it. By morning, the people came, they liked the game, they invested in that, and it's a world sensation. So designs are so important, and whenever you program, please inculcate the idea of first algorithm, whatever idea you have on paper first, draw it as a diagram, which we will make you learn the flow charts. Then you can convert it into programming. The best part of Python is both functional programming and also object oriented programming. So it can be used as procedural, and it can also be used as object oriented also. So first of all, in this course we will go for procedural type of oriented programming, then we slowly go into object oriented. Okay. So it is a mix of both C and C++ type of thing. It has all the features in it, so that's why Python is preferred by most people. Okay, right. Let us go to the explanation of few things which are really important. I'm switching off my video. I'll just share my screen. Okay. The first part is I want to discuss is the RAM, random access memory. I think this RAM you would have heard earlier. Okay, so random access memory is like we randomly access it. I will explain you what exactly these black things are. It's very good if you can do the course like NAND to Tetris in Coursera, which is free offered by Coursera to our Geetham students and also faculty. I think if you do this course, you will understand each and everything how a computer is built. So these people in Nanto Tetris, as I said already earlier to you, they will make you build a computer in a simulated environment, and you will understand because they will make you design your own RAM, and they will also make you design your own ROM, your hard disks, your CPUs. That's very quite interesting. You can register once you are allowed to register in the Coursera. See, if you did not get official mails to get registered in Coursera, you can contact the assistant principal of first year or coordinators, and you can get access for it urgently. So, because you need to do a course for Scratch also. So Scratch anyway, we will try to make you learn. We will discuss in the class. We will also give one project. Along with that, it is made compulsion that you need to do a course in Coursera for Scratch and get the certificates and submit to us. So both carries 50 percentage of marks. So if we give some marks to your project that you have done now here, and Coursera certification also is required for the full marks. So there also you do some project and submit them, they will give you the certificate that you have done this course. So this is what we are planning for Scratch. So get Coursera eligibility so that you can also register for NAND to Tetris. I will help you to do the assignment in this course. But the important part is that if you hear the lectures that they are saying, you will understand what exactly I am speaking now. I can explain each and everything clearly to you, but the problem is, there is no time for us to go for such type of courses now, because it only takes around 6 or 7 weeks of time to explain this up to assembly level language. So you can do it parallelly so that your programming level of somebody switch off your mics. Please check your mics every time. If you can, that will be helpful to us. Okay, coming to RAM, RAM is very important part. RAM helps us to see the output. RAM helps us to give the input. So RAM acts like a bridge between two things, like the computer and you. I will tell you how it acts actually. So this is the shape of RAM. So you can call it as DDR RAMs. It can be 4 GB, it can be 8 GB, and sometimes it can be 32 GB also. So day by day, RAM size is being increased. The first time I bought my computer, the RAM is around 256 MB at that time. So I just increased another 256 MB to play some games which I was really interested, and I was feeling very happy. Another 256 means it is only 512 MB, not even 1 GB. After buying the laptop, when I upgraded to 1 GB, I thought I was the person who was technically superior. I am using a lot of memory for RAM. Now 32 GB is also very, very minimum for you people nowadays. I think 4 GB and 8 GB is not even enough to play the recent games if you are really a gamer. So I used to play a few games in BTech, not few, many games in BTech. I was really interested, and through that only I got interest for programming because I want to. I was fascinated in designing some games, but of course it is not possible for me now. So after coming to job, I left over all the games and only focusing on learning many things to share with you some knowledge. I think you can enjoy both video games and also don't edit for that, but you can also enjoy video games and you can also enjoy programming in BTech, because BTech is the only thing that we enjoy in life. And after BTech, it's the real turning point. Generally, earlier my father used to say like after fifth, he said you are entering to the secondary school and it's a turning point. Okay, fine. I said I thought okay, it's a very turning point, and if I finished it, my life is good. Then after sixth, he said you are coming to seventh, it's a turning point. After seventh, he said the eighth and ninth is a turning point for 10th. After 10th, he said intermediate, next one. So it's a turning point, you study 10th. After intermediate, also is a turning point, and I started to do engineering. Then I thought after engineering 4 years, I have to decide my career. Nobody will suggest you. I have to think about whether I need to do masters or whether I need to do, job or something. Then that I thought the real turning point is only after engineering 4 years. The real turning point that they have mentioned is are also bluff turning point. You know, so because we know after sixth we come to seventh, after seventh anyway we come to eighth, after eighth you come to ninth, and so on. We come to up to engineering fourth year. If you are really interested, if you are going for medicine, you can go up to medicine fourth year or fifth year something. But after that, it's the real turning point on what to do and exactly what we need to do. Then your problem starts. So there is no enjoyment. Everywhere the worries come, and people will ask whether you got a job or not. Pakkininta auntie, edurinta auntie, odini garu, pinni garu, andaru aduguta untaru. Okay, everybody will ask. My son-in-law got Infosys job. Did your son got? Like that they will ask. Naturally we feel very ashamed of that. Okay, so it's the real turning point. So you can enjoy up to 3 years. By the time you come to fourth year, you should attain all the knowledge regarding computer science. Decide yourself whether you need to do masters or whether you need to do a good software company. Okay, if you are aiming for Google, Yahoo, Microsoft or Facebook, some type of good jobs in foreign countries or at least the branches in India, you need to do a lot of programming, competitive programming. Anyway, we are there to encourage you. You can also do it yourself. And you need to also know what are the internal parts of computer and how they work. That really helps you in doing the program. Okay. So for that, Coursera is the best option for you. Whatever courses that are not offered in Geetham can be really taken from Coursera, because Geetham is paying for you. Okay. So you can use it for free. Okay, enough for that. And coming to RAM, I will tell you how RAM helps. This is the shape of RAM. We generally put it in the slots on the motherboard. I will tell you, I will show you how the motherboard exists for this. I think I have taken this motherboard. Yeah. Yeah, this is the motherboard, and you see this which follow my cursor. These black points are there, right? These black slots are there. These are the slots in which we insert the RAM generally for your desktop computers. So for your laptops, they might be differently inserted, but the slots are the same. But they are not like this. They are not like this. You can open your laptops and you can see how they are inserted. Okay. So we insert the RAM here. I want to tell you a small story about this one. One day my computer is not working. This is really related to the functioning of RAM in our computer. I switched on my computer. Carefully listen, because you can repair yourself. Otherwise, you need to spend around 400 or 500 rupees for the service person who is doing that, just for a small point of time. One day I switched on my computer. In 2004, 2003, I bought my computer. And after a few days, I really don't know what is a computer at that time. I only know how to start it. I only know how to work it, because for the first time I'm seeing a desktop there. Of course, in my school it is there, but they're all old computers. But in engineering, for the first time I'm seeing a computer, and I'm really working with my own computer. One day I switched on my computer, the CPU is running. How I know the CPU is running means the fan runs, so I get a sound like zzz, something like that, whose sound. Then I am just sitting and waiting to start my computer. No, nothing is starting. The monitor is just blinking with its light. It's saying that no signal is there. I did not understand why the signal is not there, and the CPU is running. The system is working perfectly. The lights are glowing, and it is indicating that the hard disk is also working properly. And what's the problem? Then I was a little bit worried. I shut down the system forcefully every time. I restarted it. But whatever I have done, every time it is only showing the blank screen on my monitor. It is not showing any operating system that is loading, like Windows. Then I called to the service person. He came that day evening, and he does only 1 minute of work, and the computer started. For that, he demanded 300 rupees at that time. So I have to pay it. And after that, I contacted my friend who is good at internal parts of the computer, and he simply said that is all because of RAM. I will now tell you what happened with the RAM. I will explain you on board on what happened really with the RAM. See, we have some devices like input and output, right? So if you take this as monitor, this is the monitor, okay? And you have something like a keyboard. This is for input. So this is for input, your keyboard, okay? And you know what happens is when you come to this RAM, RAM is generally located here inside the computer. And before that, you will have something called BIOS programming, and you have something called hard disk. I will tell you why I am writing like this. This is a disk. This is a disk, and you know the disk entirely rotates, and this is called a pin. Okay, I will draw the pin in red color so that you can observe it. So this is called pin, which reads the memory while the disk is reading. And this is anyway RAM, and we have something called a CPU. This is CPU. So these are important components for loading a program or an operating system. So I generally explain you what happens really. So there is a power button that is there already. So this is power button. When you switched on this power button, this will help the SMTPS, which receives the power and transfers it. It will switch on the motherboard. The motherboard will now access this one. The first thing is BIOS. What this BIOS programming does is, this programming is already written in assembly code. This is written in ROM, a device called ROM, read-only memory. Okay. So this program which is written cannot be erasable when it is once written in ROM. What it does is, it simply goes to the hard disk. There will be OS, operating system programming files. I already discussed with you, operating system is a software which contains a set of programs. Okay. So these programs will all be loaded along with their memory locations, that means the variables, into RAM. Okay. So they are all loaded into RAM. Once they are loaded into RAM, the CPU now interacts with RAM, and based on that, it will give the output to RAM itself. So there is an interaction between them, and the final output is passed on to the monitor. So again, if you want to change something, that means you are opening a start button of your Windows something, or you are using your Zoom. Okay, you are opening your Zoom. It again takes the input from the keyboard to RAM. Now RAM and hard disk will also have interactions, and CPU will have interaction, and it will have interaction. You see, simply, RAM acts as a mediator between all of these things. Have you observed this? Without RAM, there will be very difficult for you to load the operating system and even your program. When I said operating system is set of programs which are controlling your entire computer. And you think that if it is a set of programs and there are individual programs, right? So if, for example, you are writing program 1.c or program 1.5, I think for loading this program and running this program also you need RAM. Your entire memories, which I will explain you later, like stack memory and heap memory, you just hear just now, don't get confused. If you know, that's good. Otherwise, I will tell you everything technically with proof. I will show you. So stack and heap are the memories allocated generally to the C programming or Python, whatever it might be, in which it stores its variables. For example, if you want to add two numbers, in C programming, we generally say int a is equal to 6 and int b is equal to 7, and we say int c is equal to a plus b. So this is how we write it, right? So both A and B are stored in the RAM. C is also stored in the RAM. A plus B is computed by CPU, and the final answer is kept in the C's RAM position. And then this RAM will display all the values through the monitor to you. So you will be here, and these are the two things you will see what is happening inside the computer. But these are the two things which interacts with the RAM, and the RAM is the thing that interacts with the hard disk and the CPU. Now what happened in my case is that in this slot, when I have inserted my RAM, after few days, because I did not dusted it, what happens is the dust has just gone inside this slot. And because of the dust, the current impulses have not been exactly done correctly. That means it did not receive any signal like inputs and outputs. That is the problem. There is a loose connection between this slot and the RAM which I have inserted. Because of this, the RAM did not work properly. The RAM did not work properly. It could not store the memory. It could not give output everything. So when BIOS interacted with hard disk tries to interact with RAM, and I think RAM is not working. It cannot load the entire programmings of operating systems into the RAM and their memory. And because RAM is not working, you are not seeing anything on the monitor. I hope you understand what is the importance of RAM. Did you? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So that is the importance of RAM. So if something doesn't work with your desktop or your laptops, you can just open it, take out the RAM from its slot, and then insert it again, so that you will again start the computer. It works properly. So RAM is such an important, and I will also tell you how RAM works in the programming later on. Okay, so I just started to give you like this. Okay.
Sir, there is a little disturbance in your mic. Sir, with your mic.
Okay, disturbance. So is my voice lagging?
No, sir, voice is not lagging,
No,
but
sir.
there is a little disturbance.
Okay, 1 minute. I will just switch off my fan and fan.
Yes, it's a chance.
Okay, is it clear now?
Yes,
Yes,
sir.
sir. Yes,
Sir.
sir. It's clear.
So I have also some interesting thing about how RAM works, because you will have a lot of doubt like how the memory is stored and how it actually emits. I think this is not the time to explain, but later on I will explain, maybe tomorrow, if you are really interested to know. It's a very simple thing how actually RAM stores the memory. And memory in the sense, you will get a lot of doubts. Sir has said electrical impulses like on and off. Based on this on and off, how the memory will be stored. So this is what you generally think. So it's not like a box to store some jewelry, right? So they're not entirely physical things. Entirely, this thing is called Maya. Okay, some current which we don't see is coming inside that, and based on the current on and off, it is storing some memory inside that. So while you are playing games, also RAM stores entirely your current, status temporarily. After you switched off your computer or your TV or something with the TV video games, the entire memory will be gone if you don't save it, right? So I will also explain you how RAM stores the memory later on. For now, I am just stopping this with this, and I'm just telling what is the importance of RAM, and how RAM works is the later case. Okay. Then 1 minute. Sir, good morning. Sir, class lo unnanu. Anything urgent? Okay, sir. Okay, fine. Okay. So after RAM, The next thing I want to go for is ROM. So ROM is actually read-only memory. That means it's not a random access. You will understand after I explain how the RAM stores the memory. Then you will understand why it is called random access memory. Until then, you will get it out why it is called random access memory. For now, I will give a hint like it is randomly accessed. Okay, you need to access an address wherever possible, like in your iPad or something, iPod, you just go directly to your song, which song you want, right? So randomly you are accessing whatever song you want. Like that in RAM, it is eligible for randomly accessing some memory location and get that memory. I will explain you why it is called random access memory. When technically explained, you will understand why the name comes. Okay. The next thing is ROM, which is read-only memory. Read-only in the sense it is not eligible for writing something in that every time. Still, the recent developments in ROM also place the same principle of only reading only the memory. So in ROM, there are three types. One is called only read-only memory. That means once you write something in ROM chip, that cannot be erasable. If you want to change something in the ROM, programming that you write in ROM, you need to just pick it out from your motherboard, throw it away in the dustbin, bring a new chip and write a new program and insert it into the motherboard for working out. Okay. But there are some things due to wastage of silicon wastage antaru deenni rose ki silicon wastage ekku avutundi, and to eliminate this wastage people have come up with two ideas. One is called EEPROM, that means electrically erasable programmable read only memory. So electrically erasable programmable read-only memory. That means once you write some program into ROM with electrical impulses, you can just erase all this memory in this simply like this, and you can again write your new program. So using electrical impulses, you can send some electrical impulses to erase that one, and you can write the program again. The other thing, the latest technology that we got is EPROM. Sorry, EPROM. This is called only erasable programmable read-only memory. Okay. So how it erases is, you can see this is called EPROM. We send some ultraviolet rays. So ultraviolet rays generally kills a virus, right? Why can't it erase a memory? So we send some ultraviolet rays to erase the whole program that is written as zeros and ones, and we can rewrite the program. So this is how ROM works. So recently you can directly go for erasing. You need to pick up this chip from your motherboard. You see, ikkada chusara, you see, follow my cursor. You have pins here, right? These pins are inserted into the motherboard. Motherboard lo oka slot untundi, danlo insert chestara pins ni తీసుకెళ్ళి. సో ఇక్కడే గ్రౌండ్ అని వోల్ట్స్ అని మీరు ఫిజిక్స్ లో చదువుంటారు. ఓకే, ఇవన్నీ ఉంటాయి. సో కనెక్షన్స్, ఇన్పుట్ అవుట్పుట్ అన్ని ఆ పిన్స్ ద్వారానే వెళ్తూ ఉంటాయి. సో యూ నీడ్ టు అండర్స్టాండ్ దట్ యూ నీడ్ టు పిక్ అప్ దిస్ చిప్, send some ultraviolet rays, erase the already written program, rewrite the program and insert the chip back into the motherboard, which I have shown now, just now. Motherboard చూపించాను కదా, అందులో ఇన్సర్ట్ చేస్తాం మనం motherboard మీద. Then it works properly. And nowadays there is something called flash memory. Flash memory గురించి వినే ఉండుంటారు. ఇప్పుడు లేటెస్ట్ ల్యాప్టాప్స్ అన్ని ఫ్లాష్ మెమరీ అండి అని చెప్తున్నా. So flash memory is eliminating this particular read-only memory. Flash memory lo one advantage ఏంటంటే there is no need to pick from the motherboard, do something and outside and get it back. Flash memory motherboard మీద ఉంచుకొని మీరు అక్కడే ప్రోగ్రామ్ చేయొచ్చు. You can easily erase it and you can also rewrite the program. So ROM దేనికి ఉపయోగపడుతుంది? How the ROM will be used? ROM is used to write something called BIOS. So if you see this as ROM, so it looks same like this, right? See, like this one. You can see different ROMs. These are different ROMs that you have. Earlier ROM that is a little bit crazy. You see how much big it is, and you see. Is there any similarity between the BIOS chip that it is showing? Yes, I think. See, inside that circle, you can see both are looking the same. That means BIOS chips are nothing but ROM chips. You can see this is upside down. Both things that they have just reversed it. So these are the pins that you can find, which you can insert into the motherboard. So the program called BIOS, Basic Input Output System. So the program called BIOS is called Basic Input Output System. Or software, whatever you want, you can call. So this BIOS is written in this particular chip called ROM. And you know what is the thing that BIOS does is, it loads the operating system into the RAM so that you can work out with the operating system by seeing through the monitor. Okay. So remember, every time you write a new program, operating system will help you to load it, will ask the CPU to execute your program. So operating system is a pilot. But before operating system also comes, it also needs to be loaded, right? Antena? So remember one thing, if a pilot is controlling the ship, but initially pilot should also be loaded onto the ship, right? So if you see your computer as a ship philosophically, operating system is called the pilot of the computer because it controls everything. It tells what the CPU has to do. It tells what the hard disk has to do. It tells what the RAM has to do. But initially you need to load operating system into the RAM. Then only operating system comes into life and starts controlling your entire computer. For that, there is a small program which is written in 4 or 5 lines of code and that is kept in ROM. The main task of BIOS is it starts to take all the files of operating system from the hard disk, load it to your RAM. Once loaded it to your RAM, your operating system comes to life. So it starts working. It starts interacting with the CPU. It starts interacting with the hard disks. It starts interacting with all the drives that you have, like your USB and all. So this is how operating system is loaded using BIOS. So BIOS is very important. So I have told you now.
Excuse me, I too.
1 minute. So I have told you now what is the importance of ROM and what is the importance of BIOS. So ROM lo BIOS load avutundi. Once BIOS is loaded, this program called BIOS will load the operating system initially. So you need to remember, for the first time you are switching on your computer, the program that first runs is called BIOS, Basic Input Output System. This BIOS programming will start loading your operating system. So you should not say my operating system is loading whenever I switch on your computer, but you need to say what works first. When you switch on your computer, BIOS works first. BIOS programming will now load your operating system. That's why you see your operating system loading and a message vastundi, right? In Windows or Mac or Linux.
Yes, yes, sir.
This is actually loaded by BIOS at that time. Okay, this is the importance of everything. Then coming to CPU. Okay, now CPU is a very small chip. Generally, in 4th year, once I have gone for a small Viva for a hardware lab, what happened is I asked the people, can you show me what is CPU? They are showing something in the corner. I was just, they're just pointing out towards something in the corner. I was just looking and I did not find any CPU. Then I asked, what is CPU? Why are you showing there? They said, sir, that box is there. No, sir, that is CPU. You know, box is a dabba. That is not at all CPU. How we call a box as CPU? It's a misconception. A box is containing a motherboard. It contains RAM, ROM, hard disks, the disk drives and CPU in that. So you cannot call a computer's box that you are seeing as a CPU. That's only called a box, a computer box. which holds every component of the computer. But CPU is a very small chip like what you are seeing. It will just adjust in your palm, very small. You can see here. This is the reverse of a CPU. These are called pins through which your current impulses will go. That means whatever addition you want. In this, ALU is there, arithmetic logic unit is there, all the logic units are there, the NAND, XOR, every gate is there here, which you have studied in your physics might be. So these are all given in a very small chip, and these are the pins through which your electrical impulses like zeros and ones will go inside the CPU. And these are all made up of gold. Why gold? Is because gold is a good conductor of electricity and it never rusts or spoils. If you use iron, iron might rust, and someday you are because if it, see, I said already, if there is some dust itself, the RAM didn't work in the slot properly. But if you imagine that you used iron here, because of iron, what happens is the entire iron get rusted someday, or steel, whatever it might be, and it doesn't pass the electrical impulses. Because of that, your computer might show an error. So gold helps us a lot. Maybe it is 1 gram gold or something, maybe less than 1 gram also. So that's why we say silicon waste contractors go under. What they do is, after they collect all the waste, like all the motherboards which are not working, they get to their garbage location. They just collect all the gold from this, and sometimes they get a lot of gold by this. Collecting a huge some tons of computers, they can collect something like 1 kg of gold, something, because a ton means you have a lot of gold inside that. And they use two main important things to design your computer. One is gold and the other one is silicon. Silicon comes from a sand type of thing. You can see in YouTube how silicon is used for designing the memory. That's really important. You are also surprised that while you are designing these CPUs and using silicon or gold something, the people who go inside the laboratory will all have PPE dresses, like how now doctors are wearing for corona, right? There should be no dust, there should be no viruses, there should be no bacteria to spoil all these things. So while they are manufacturing these things, they are very pure in their air also. The air is entirely purified every time. So this is how the CPU appears. I will tell you how CPU works while you are doing a program. Okay, that's enough for you. There is no need for you to learn more about CPU. I also want to show how the earlier CPUs used to be. So this much big is your earlier CPU. It is like a slate. In our childhood we used to take slates with us in our LKG or something. So earlier, when Apple Macintosh is being designed, these many chips are there for the CPU. And Steve Wozniak has done some important thing, like he has reduced the number of chips and he has compacted this particular CPU working. And by this, people started a revolution of desktops. I think IBM and Apple had a competition for launching the desktops into the market. Until then, when you want to go for working out with computers, generally, I had an old professor to whom I have interacted. He done his PhD in IIT, it seems. He want one calculation. He took an appointment with the programmer, because at that time the computers are mainframes and they occupied a whole building that is called computer building. These people went there, they stood in a queue actually, and that queue is also to the people who took already the prior appointment. They used to give small computational logic, and this programmer used to program all the computational logic, and finally the answer will be given after 1 week. They only gave the question. After 1 week, the program will be written by the programmer, and then the output will be given to them. So earlier, if, for example, for electronics or mechanical, they want to test some inputs and get the outputs, right? For that also, they need computer calculations. And for calculations, they used to take 2 weeks to get the input and output. And there is a revolution in America to get personal desktops to the people who are working individually in their own offices or homes. For that, the Apple and the IBM have competed with each other. And Steve Wozniak is very intelligent to reduce the number of chips that were there in the CPUs. And the CPU was compacted a little bit. And the first Apple desktop was launched. It was bought by some person in New York or something. I don't remember what is this. And at the time it was made up of wood. You can see it in Apple One something. You see how crazy it is and how funny it is at the time, the Apple computer. Later on, they started to get the vendors and they started to launch this one in a mass production, Apple II, which was a great hit along with IBM computers who are using Windows. Okay, this was the appearance of earlier CPUs, that much of big, and you see, compare between them how small it is. How small it is, you see now. So this much of big in 1940s and 50s, the CPU. See how much big it is, like a birva. And slowly it is reduced to very small. And this is also one part of CPU, which was also very big. You can imagine how big it is now. And this one also, very big CPU that is in a box that was kept. This one also. So now you see a very small CPU later on, okay? So this is the slot for your CPU on which the fan will be there. If the fan is running, that means your CPU is now running and your fan works, because CPU emits a lot of heat while it is working out. So now your CPU is inserted into this slots. You can see the slots here. All the gold pins will be inserted correctly into this, and you start working with the CPU. So this is the diagram how the CPU works. You have control unit, resistors. I will tell you what is a resistor and what is a bit when I am explaining you RAM tomorrow. It's very important and a very interesting concept if you're really interested to learn what happens in the computers. So main memory is the RAM memory. It interacts it will show you the diagram how it interacts, the input and output, and in between you have CPU. You can go to Wikipedia and study all these things because they are clearly explained if you are really interested in that. Okay, coming to the next concept called SSD and hard disks. So this is called SSD and this is called a hard disk. You see a disk is there, the pin that reads the disk. The pin is like, it is only slightly above the disk. It doesn't, rub the disk like this. It doesn't touch the disk. If it touches the disk with the speed the disk rotates, the disk might break. So while it is inches above the disk, it can read what is the memory on the disk, because it's a electromagnetic impulses. This pin is the main thing to get the memory from the hard disk. Whatever programs that you write and store in the hard disk will be taken and written by the pin itself. This disk is only for saving some electromagnetic impulses which are in zeros and ones. Your entire programming memory or games or operating system is stored in the disk. It is input and read, that means the output, by this particular pin, which I am now showing. So when people are using hard disks are a little bit, clumsy, and they took a lot of space. Because of this, this also produce a lot of sound and heat because it is rotating very fast. To reduce the laptop size, people are now using something called SSD. SSD is something like called solid state disk or solid state device, we can call. And now whenever you buy a laptop, they will say, sir, this laptop is having hard disk and this laptop is having SSD. I most probably prefer SSD because SSD is fast in writing and getting the data back. And SSD is very small and compact. That's why your latest laptops are very small. It can have, 64 GB or 128, 256, 1 TB also it can hold. So you can see what is there inside the SSD. Lot of resistors are there to store the memory. So SSD don't have any disk. It is only having the memory like your USB. If you see USB, how it is storing everything. The same way, SSD is also having no disk, but it has a capacity of storing something like a hard disk. So it doesn't produce any sound. It only stores the memory and sends the memory. So this is all about your SSD and HDD. So hard disk drives are called HDD and we call this one as SSD. So if you are buying, preferably buying a computer, go for SSD, that will be very good. Now all the Mac Pro and MacBook Air are producing only SSD, I hope, and flash memory. They are not even using ROM and BIOS. BIOS programming is written is in flash memory, and your hard disk is an SSD. So that's why you have less sound from these laptops and less heat from these laptops. That is the reason. So this is all about the hardware that is very important for your programming. That's why I have explained it today. I will now tell afterwards, when you are coming to programming, how your program is being fed to what, how RAM takes a part, what operating system plays a part, and how CPU works for processing your programming, what is the role of hard disk. Everything we will discuss later on when we come to programming. So I think this is today's class. You have only 4 minutes of time to migrate. So I think we can stop it today. Is it okay today? Have you understood?
Yes, sir.
Yes, sir.
Right. So we will stop the class for today. Right. Sir, Sanu sir, shall we, sir? Or you will talk something? Shanmugh sir? Yes, is there any doubt, Ram Raju? Yeah, ask me.
Sir, why HDD is cheaper than SSD?
Yeah, the HDD is a very old technology, and at that time, something that might become cheaper. Like earlier, when I bought my computer, everything is very costly. At the time, I bought with some 40,000 or something, right? The same computer now it is sold for 20,000. The personal desktop. The reason is old technology will always have reduced prices because you have a bunch of availability. But SSD is a modern technology. It has all modern equipment in that, and it's so powerful when compared to hard disk. That's why your rate also might increase, because it is reducing your size of your laptop and your computer. So naturally, the vendor will demand some price for you. Okay. Yeah.
Thank you, sir.
Yeah.
Sir, what is the difference between ROM and hard disk, sir?
ROM is like it is a very small memory. It doesn't store like a hard disk like 1 TB. So, somebody switch off your mic. So once you write in ROM or a flash memory,
అర్జెంటా
come on, man.
వస్తున్నాను
Okay, something that you write in ROM. So if it needs to be erased, it's not so easy to delete it. You need
ఏటీఎం ని బ్యాంక్ అదే ఇదేనా బుక్ ఏమక్కలేదు బ్యాంక్ బుక్
people doesn't see what they exactly need. Okay, so for once you write a program in ROM, it is not so easy to erase it, but in hard disk it can be easy. Okay, so both stores them permanently, persistently, but ROM is very small size and it only stores BIOS programming. You can expand the ROM size, but if something you want to delete from ROM, it's very difficult to delete it because you need to either use an ultraviolet rays or electrical impulses. But for hard disk, it's not that much difficult. You go there, delete it or push it into the trash. Everything will be deleted from the hard disk. Okay, understood?
Yes, sir.
Yeah. Right then, I am leaving the class. I will post the recording to you. Bye bye.
Thank you, sir.
Bye.
థ్యాంక్ యూ సార్
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah, thank you. Bye all.
Thank you, sir.
I'm ending the session, sir.
9 o'clock.
Okay, sir. Okay.
Right.